Hello everyone, Mr. Fawcett here, and we are back with another geometry lesson. This is actually the last lesson in Unit 3, and we're going to talk about lines in a coordinate plane. So we're going to talk about specifically how to write the equations of lines. If we're given a slope and a point, or maybe 2 points, or maybe we're asked to write the equation of a line that's perpendicular to another line or parallel to another line. So more algebra today than what we're used to consider in geometry, but it does fall under the same umbrella. So before you start, or before we get into new stuff for today, you have 2 problems. All you're doing is solving these equations for y. So your goal is to get y by itself. So take 2 or 3 minutes, pause the video, and rearrange those equations. All right, so for equation number 1, that one's pretty straightforward. We're just going to add 6x to both sides. So I get y is equal to 9 plus 6x. Of course, you could also say y is equal to 6x plus 9. Either one of these would be acceptable. If we move on to equation number 2, first thing we're going to do is subtract 4x from both sides. So I get negative 2y is equal to negative 4x plus 8. And then I have to divide every term by negative 2. So don't just divide one of the terms. Make sure you divide all 3 in this case. So I get y is equal to 2x minus 4. Y is equal to 2x minus 4. Okay, let's move on. A lot of this lesson is going to be review, as long as you went in depth in this topic in your algebra class. We have 2 equations of lines that we're going to work with, right? We have point-slope form. That is listed right here. So that's my y minus y1 is equal to m times the quantity x minus x1. This may be a little bit more unfamiliar to you because it seems like until you get to this point, we've more worked with slope-intercept form, which is down here, rather than point-slope form. But actually, point-slope form is what you'll probably work with more so from here on out. I'm talking with my calculus kids about this topic, and we always start with point-slope form. A lot of times, there's no need to go to slope-intercept form. Point-slope form will suffice. And it's actually generally easier to write an equation in point-slope form to start off with. So that's what we're going to work mainly with today. If we look at 2 other equations, x equals a number, so something like x equals a and y equals a or y equals b. These are equations of vertical or horizontal lines. So if we think about a graph, and again, this is just a quick review. If I have an equation x equals 4, that is going to be the vertical line that goes through x equals 4. So that line would look like this. If I wanted to do the line, this one's going to be a little, actually let's do red again to keep it consistent. If I wanted to do the line y equals 2, well, that would be a horizontal line through 2 on the y-axis. Okay, so that's what they say. When they say the equation of a is the x-intercept, that just means that that's a line that goes through that x value. In this case, it's x equals 4. Same thing for y. If you have an equation y equals a number, that is just a horizontal line that goes through 2 on the y-axis. Okay, let's start putting these equations to use. Before we do that, though, let's revisit yesterday or last video. Write down the difference between parallel and perpendicular lines, or how you know that 2 lines are perpendicular and how 2 lines will be parallel. So touch on both of those, and then we'll make sure we're on the same page about what parallel and perpendicular means. All right, so I just typed it because that was a little bit easier than writing it out. Parallel lines have the same slope and different y-intercepts, and perpendicular lines have opposite reciprocal slopes. So again, we'll touch on both of those again as we move through these practice problems. If you're unsure of what those mean, what it means to have the same slope and different y-intercepts, or what opposite reciprocal slopes mean, you may want to go back and watch the video from 3.5 because we do cover that pretty in depth. All right, so we have some practice. This is just like yesterday, or I keep saying yesterday, depends when you watched the last video. Just like the problems from 3.5. So I'm not going to go over these. The last 3 problems in the 3.5 packet are similar to these, so if you need help, you can go reference those and my explanations on the video. But basically, you're going to find the slopes and you're going to decide whether the lines are parallel, perpendicular, or neither. We are going to skip down to writing the actual equations of lines. So this is where we're going to spend our time today. All right, so number 1, it says the line with slope 3 and that goes through the point 2, 1. And it's asking us to write in slope-intercept form. So while our end goal is to write in slope-intercept form, we are going to start with point-slope form. So I'm just going to write down the general formula for point-slope form so we can start working with that. So we have y minus y1 is equal to m times the quantity x minus x1. And we know that m is our slope, and x1 and y1 are the coordinates of the point that we're using. In this case, 2, 1 is going to be our x1 and our y1. So let's just start building our equation. I have y minus y1, so y minus 1, again, that's given as our point, equals our slope, which in this case is 3, times the quantity x minus x1. In this case, x1 is 2. So there's the equation of a line that has a slope of 3 and goes through the point 2, 1. Now they're asking us to write it in slope-intercept form. So we just need to do some algebraic manipulation to get y by itself. Slope-intercept form, I think that's the one that's more familiar to you at this point. It's the y equals mx plus b. So I am going to distribute my 3. So I get y minus 1 is equal to 3x minus 6, distribute to both the x and the negative 2. And then I'm going to add 1 to both sides. So I get y is equal to 3x minus 5. Negative 6 plus 1 is negative 5. So that would be our equation in slope-intercept form. Number 2, we want the equation of a line that goes through the points 0, 4 and negative 1, 2, and we need to write it in slope-intercept form. We're going to start with point-slope form, though. Today, we're always going to start with point-slope, and then we're going to work our way towards slope-intercept. I'd pause the video right now, and I'd see if you could work through this problem. It's a little different than number 1 because they just give you 2 points. So they don't give you the slope. They expect you to be able to find the slope from those 2 points. So that's my hint. My other hint is that it doesn't matter which point you use as x1 and y1. You could use 0, 4, or you could use negative 1, 2, and your slope-intercept form equation will still come out the same. So pause the video, take some time to work through this, and then come back and see how you did. Okay, so the difference between this one and the previous one is that we actually have to find the slope. So change in y over change in x. This is going to help us find the slope of the line. So that's going to be equal to y2 minus y1. So I'm going to go 2 minus 4 all over negative 1 minus 0. That's going to give me negative 2 over negative 1, which is equal to 2. So our m, our slope, is 2. Now I'm going to choose 0, 4. It's quite easy to work with 0. So if there's a coordinate that's 0, it's might be beneficial to choose that one. But it doesn't matter. You'll get the same equation either way. So I'm going to have y minus y1, so y minus 4, is equal to our slope, m, which is 2, times the quantity x minus x1, which is 0. And I'm actually going to write the other one out just to show you that we'll get the same thing. So I get y minus 2 is equal to 2 times the quantity x minus negative 1, so this becomes x plus 1. And now we're going to put both equations into slope-intercept form, and you'll see we get the same thing. Let me go back to my green. I get y minus 4 is equal to 2x. If I add 4 to both sides, I get y is equal to 2x plus 4. If I come over to my orange, I get y minus 2 is equal to 2x plus 2. And then if I add 2 to both sides, I get y is equal to 2x plus 4. So again, it doesn't matter which point you use. As long as you find the right slope and substitute correctly, you're going to get the same equation for slope-intercept form. All right, let's see what type of problem we have next. I'm going to move this down, actually. All right, so this one is asking us a different question. And we keep moving this down so we have more space. So it says we need to find the line that is perpendicular to y equals negative 1/3 x plus 6, and it needs to go through the point 5, 12. So we are going to start off, as usual, with point slope form. So we need y minus y1 is equal to m times the quantity x minus x1. Now this is just kind of like a puzzle. We have three things we need to find, right? We have x1, we need y1, and we need m. Well, we already have x1 and y1, right? That's 5, 12. So I can start, and I can do y minus 12 is equal to m, which I don't know yet, times the quantity x minus 5. So I just need to figure out what m is. It says that we need to find a perpendicular line. So remember that perpendicular lines have opposite reciprocal slopes. So the slope of my original line is negative 1/3. Well, if I have negative 1/3, the opposite reciprocal, right, we are going to flip the fraction, so 3 over 1, and we're going to switch the sign. That's what the opposite part means. So I switch the sign from negative to positive. I don't have to write positive, and then I get this is equal to 3. So my new slope is 3. And this time it doesn't tell us we have to write this in slope-intercept form. So we could leave it in point-slope form. If you wanted to write it in slope-intercept form, again, just do your distributing. So I get y minus 12 is equal to 3x minus 15. Add 12 to both sides, so I get y equals 3x minus 3. Now here's the thing. Both of these would be correct answers to this question. However, if you didn't stop at the red equation, if you didn't stop with point-slope form, and you continued on, let's say you made an algebraic mistake when you distributed or when you added 12 to both sides, you wouldn't get credit for that final answer, right? Because if you put too much work and there's incorrect work, right, you're going to lose some points. But if you do what's needed, if you stopped at point-slope form, which was what's in red, because they don't tell you to go to slope-intercept form, you're good. You stop, and there's no chance that you lose any points for doing extra work that was incorrect. So it's good to know how to do it, but it's also good not to take a risk and lose points if you don't have to. All right, let's move on. All right, so number 4 says you're finding the line that's parallel to this line, and it needs to go through the point 6, negative 2. So same process as number 3, except you're now finding a parallel line. So you need to think about the types of slopes that parallel lines have, and then do your best to fill in point slope form. Take a few minutes, pause the video, and see if you're able to do this one. Okay, so you should know what I'm going to start off with. I'm going to start off with my point slope form, and then just try to figure out which pieces go where. I'm already given my point, so I can start there. I'm going to get y minus negative 2, so it's y plus 2, equals m, which I don't know yet, is equal to, y plus 2 is equal to m times the quantity x minus 6. Now we need to figure out my m. Well, I know that I'm doing a parallel line to this line, 4y plus 6x equals 30. Well, what's the slope of this line? Parallel lines have the same slope, so if I know what the slope of this line is, I know what the slope of my new line is. The problem is I need to put this in slope-intercept form for me to find the slope. So I'm going to move my 6x to the other side by subtracting. And I'm going to divide everything by 4. So I get y is equal to, if I simplify, I get negative 3 halves x plus 15 halves, which means my slope is negative 3 halves. I'm going to put that in there and box my answer. Again, no need to convert it to slope-intercept because it does not ask us to. All right, let's see if we're going to do any more. We may just call it a video and have you attempt the rest of the ones on your own. We're actually going to, so you are going to try numbers 5 and 6 on your own. One of them's a graph, one of them's another algebraic problem. But then we are going to jump down to the application problem, so the word problem. All right, so it says Audrey is trying to decide between two health club plans. After how many months would both plans' total cost be the same? So we have plan A, $140 to enroll, and then a monthly fee of $35. And then plan B is $60, but it has a monthly fee of $55. So we want to see how many months does it take for the two plans to be the same. I'm not going to give you any help right now. Pause the video, see if you can set up an equation to solve this, and then figure out what that number of months is where they both cost the same amount. My one thing I do want to tell you is that you will need a variable here. Come up with whatever variable you want, but make sure you tell me what it represents. So on your paper, you should say let blank, whatever letter you choose to be a variable, represent such and such. All right, so we actually can just write one equation here. We're trying to figure out when plan A, the cost of plan A, is equal to the cost, let's do a different color. In my pen, there we go. The cost of plan B. So we have an equation in words, and now we need to try to change those words to some combination of letters and numbers. Well, let's think about it. The cost for plan A is $104, still on blue. The cost for plan A is $140 plus $35 a month. So I don't know how many months it's going to take, so we're going to do 35 times a variable. Let's use m for months. And then over here, I'm going to say let m represent number of months. You are free to use x, you're free to use y, you're free to use whatever variable you want as long as you tell me what that variable stands for. For plan B, we have $60 plus $55 a month, so 55 times m, and now I have an equation that I can solve. So again, I started with something in words because that was just easiest for me to kind of just talk through what type of equation I need, and then I changed it to letters and numbers based on what the data in the problem said. I am going to subtract 35m from both sides. So I'm going to get 140 is equal to 60. If I subtract 35m, I get 20m on this side. I'm now going to subtract 60 from both sides, so I get 80 is equal to 20m. I'm now going to divide both sides by 20, and that is going to give me m is equal to 4. So we can say after 4 months, plans cost the same. You guys have a little bit more space than I do, I'm sure, to squeeze that in. But it is important to write a little, let's change that to a better E. It is important to write a little concluding sentence to make sure the reader knows exactly what your solution represents. Okay, so you have the 2 problems up above you can try, but that is going to do it for this video. So enjoy the rest of your day. I look forward to seeing you next video where we will be starting a brand new unit.